All right, good morning, everyone, and welcome to the RSA conference. Thanks for being here bright and early on Monday morning. My name is Ben Jun, and I'm here to lead you in the crypto, blockchain, and cryptocurrency track. Most of you are here because you have, well, some interest in this, but I'm also sure that almost all of you have had someone approach you sometime last year, someone who you would never have actually expected to talk to you about crypto, key management, financial transactions, and tell you that they were investing in these currencies. And so it's a very interesting time, and we've seen a lot of these systems be basically validated through the amount of money that's been transacting through these systems. There's also a lot of promise for what we hope these things will deliver, and so I hope that we can talk about those things this morning. I think there's three reasons why we chose to do this thing at the RSA conference. The first is that a lot of the underpinnings for blockchain, cryptocurrency, come from cryptography itself, the same underpinning of our field. And so the same techniques that allow us to secure enterprises are also being used in this massively decentralized way. We should learn about it. The second reason I think it's important for us to focus on this is these technologies are changing how enterprises will transact. They're changing and pushing certain classes of transactions to the edge. They're also looking at users' identity and roles in very, very different ways than the ways that we look at them today. And so I think we need to follow it. And the third is that any time that anyone's got billions of dollars running around that's been attacked and is successfully defending itself against these attacks, I think it behooves us to understand how it works and see what we can learn from it. So just a couple of interesting vanity stats here. If you take Bitcoin, which is a cryptocurrency, and you are to look at the market cap of Bitcoin, which is to say, what does the Bitcoin trade at against the US dollar, and convert all of the Bitcoin into US dollars, what is that? You'll see some interesting things we plot here. Last year we had what we kind of called the summer of crypto, where suddenly in a matter of just a few months, the value of the Bitcoin sort of doubled in price against the US dollar. October of last year, we had more users on Coinbase, which is a system, a platform for transacting cryptocurrencies, than there are users on Charles Schwab. And then in December of last year, we had really a peak of the Bitcoin's market cap. And at that point in time, the total value of Bitcoin in circulation was about 1/10 the amount of US hard currency in circulation, and about 1/3 the market cap of Apple. So we're talking about a serious thing with sort of big numbers behind it. Now what we're going to do with our time sort of this morning and early afternoon is I've split this track into three portions. We're going to spend the first time, part of the morning, talking about fundamentals of Bitcoin, blockchain, smart contracts, tokens, ICOs. It'll be with myself and my friend Linda here. The second part of the track, just before lunch, we'll talk about applications. We're going to focus more on applications that are enterprise related. Chain is a great company doing really good work adapting the blockchain to enterprise applications. We're going to hear from one of their engineers on how they do this. We're going to look at a case study and how this is used for medical data. And then we're going to look at some of the legal implications for running your business on the blockchain. Now finally, after lunch, I hope you come back because the main focus will be on kind of what we like to do at this conference, which is talk about attacks and bad stuff. We have a great talk from Diogo from a stealth startup that's actually working on how to protect keys in a very aggressive way, followed by some a great discussion of people on the legal and regulatory side on what happens when blockchain actors go bad. And they've actually put people in jail, and they'll talk about that process and that experience. So I hope that you're in the right place, and I'm enjoying the conversation I will enjoy the conversation that we're going to have. So let's first talk about how the world changed. In 2008, someone, which is not really a person, named Satoshi Nakamoto, introduced something called Bitcoin, which he, she, they referred to as a peer-to-peer electronic cash system. And this is really the underpinnings of what we run Bitcoin, blockchain, and the crypto world on today. And there's a couple of key words that will jump out when you read papers like this. And I just want to go through them quickly because you're going to see these again and again today. This is a peer-to-peer system, and that means that it operates where people can transact directly with each other without the need of some sort of centralized party to find each other. This thing uses digital identities and signatures. The same ways that we create X509 credentials today, we're using some of those same properties to create identities and transact on the blockchain. There's no trusted third party, which means that I'm not relying on the government, I'm not relying on the judge to arbitrate a transaction. This is decentralized. The internet is designed to be kind of hard to squash. Major portions of it can go out and life will still continue. This thing has the same properties. It was designed to kind of live for a long time, and it was designed to live against a world of censorship and regulation. And finally, we have a different way of looking at value, something we call proof of work. And we'll talk about that as we go. So these are the concepts that I hope you can keep with you as we kind of look on today. And when I introduce Bitcoin to people, usually the best way I try to do this is to, instead of talking about how it works directly, let's talk about societal concepts of things like money, contracts, and records and logs. It turns out that Satoshi's world changes how some of these things work with technology in ways that are quite powerful. But we almost have to look deep inside and figure out why we transact the way we do before we kind of start looking at this. So what is value? Value is something I have in my pocket. It's something that I know is rare. And if I know it's rare, then I can then use it to go buy something else with it. So the principle of supply and demand holds here. If the amount of gold in the world is relatively understood and we have some idea of what the reserves are, we can declare that to be rare. And because it's rare, I can then use gold for something else. The more stable the supply is of this asset, the more the value of this thing fluctuates with demand. And so the coins you have in your pocket are relatively stable in terms of supply because our government has decreed that it will try to keep it stable. But the actual value of that coin is based on the demand in the world for that thing, right? And so what we think of as sort of sacred, this piece of value, is really this thing that just fluctuates anyway. Also, traditionally, the way that we have extracted value is through something called mining. We will actually spend a lot of resource to dig big holes in the ground, find things that we think are rare, melt them down, process them, and then transact with them, right? And if the cost to perform the extraction is less than the cost of the token, we will go ahead and perform these mining operations. And so purely out of selfish interest, these people are going and finding metals that we can melt down and sort of use to transact as currency. Sort of a weird thought, isn't it? So what Satoshi did was he said, you know, I like these principles. What I want to do is figure out how we can do mining some other way. And so he used mining in what's called a proof of work. So instead of spending resources to dig big holes in the ground, we are spending compute and electrical resources to solve certain kinds of math problems. And the math problem that we have here is SHA-256. Most of you are familiar with SHA. You've probably used it several hundred times today. It's used in the TLS framework. It's used in digital signatures. It's also used to hash passwords. It has this nice property where I can take an incoming message of arbitrary length and digest it into a specific message digest or fingerprint at the bottom. If it works properly, the digest looks kind of random. And it's also very hard for me to go backwards from the digest to the incoming message. That's why we use it for password hashing. And so what Satoshi did was he set up a little math puzzle. He said, I would like to every once in a while declare that whoever can find me a piece of data that hashes to a specific magic value wins a prize. And that prize is basically a couple of bitcoins that will reward the finder. And you'll look at the bottom of the page here, and you'll see what looks like a bunch of random hexadecimal numbers, except that it's not totally random. A lot of leading zeros there. That's not a mistake. The Bitcoin system actually requires you to find hashes that are low, in other words, have structure to them. And we understand that the best way to do this is basically brute force. And so just like we go and dig holes in the ground, we use equipment that looks like this. We use equipment that looks like this. This is a modern mining tool. These are GPU cards from NVIDIA. Their initial application was to help people render things like video games and movies more quickly. It turns out that these cards are optimized to do a lot of operations in parallel. When I'm playing a video game or looking at each pixel is rendered using an algorithm which is pretty much similar to the other pixels, so that rendering can be done in parallel. It turns out that that's very similar to the class of work that we do for mining, and so these cards are used for that. Something else should jump out at you, which is all the red circles. You can't actually buy this stuff right now. It's actually very hard. This is another supply and demand problem. People are buying these things because it costs them less money to buy them and run them and mine bitcoins, which they can then sort of transact with at a profit. And so you're seeing one of the effects on the system where mining is already a significant portion of the world's resources. We're spending something like 1% of the US's energy around the world right now on mining operations for Bitcoin and blockchain. All right. So the next thing I want to introduce you to is contracts. Generally speaking, when you look at value, if I had coins in my pocket It's pretty easy for you to understand who owns those coins. I have them. And it's pretty easy to understand how to transact with them. I'll take your hamburger and I'll give you a couple of these coins. But once you start looking at bigger objects and more complex things, we can't really just do it with physical tokens. We need something else. And so let's take a look at an example here. Let's look at a car. A car is just big enough where, yes, I can keep the car in my garage at night, but it's just more expensive enough and just big enough where I might need some better way to declare ownership of that item. And so in California, we have this thing we call a pink slip, which is basically the certificate of title for your car. And Alice has a car. She has the certificate of title. If she wants to sell that car in the parking lot to Bob, all she has to do is sign in 2 places on the top, declaring that she relinquishes her right to the car. Write Bob's name on the back. Bob can take that to the California DMV and get a new pink slip. And so what she's basically done is she has facilitated a peer-to-peer transfer to Bob that was then sort of officially recorded and recorded as a new certificate. And if Bob wants to sell his car to, for example, Cheryl, he can go and do the exact same thing. He can sign the front, put Cheryl's name on the back, and that car will then become Cheryl's. Right? And so this is a peer-to-peer contract that we're actually very used to using in our daily lives. Right? And just like other things in technology, the world changed. Probably the best invention in cryptography in the last 100 years occurred in 1975 with Merkle, Diffie, and Hellman basically inventing public key encryption. It led to Rivest, Shamir, and Adelman also inventing their take on it, which of course became RSA the company, which is largely in part why we're here today. But digital signatures basically introduced something very important. Introduced 2 keys where I would hold the private key very closely to myself. And I could use that private key to encrypt or authorize various transactions. And you can prove that it's me by simply taking the other key, the public key, that's widely disseminated. And once I have this, I have a digital analogy to basically using a handwritten signature, which is basically created by some biometric of me, my hands and my muscles, and then giving you a means to verify that. So let's take that to the contract world. Let's say the first 2 times we transacted the car, we did so using pink slips. But the 3rd time we transacted the car, we did so using an electronic contract. This is actually the description from Satoshi's Bitcoin paper. So it turns out that the process of transacting a digital good is pretty similar. There's 3 important things on this digital contract. The first one is a reference to the actual asset, and we do that by hashing the contract before it. In other words, this is the same car with this VIN on it. The second thing we do is we have a concept of who's going to own the car next. We have a public key for that person. Finally, we have to sign the thing. And instead of signing it on the front in 2 places, we use the private key of, in this case, Cheryl, to sign that document. That car is now Dan's. And if Dan wants to, he can sell the car again. Right? So we now have a digital way to basically do what we used to do offline. So third part that I think is important. And this is ledgers. What's a ledger? Well, ledgers have been around for a long time. And there's a person that you probably haven't met called Luca Pacioli. He was a contemporary of Leonardo da Vinci. And in fact, Leonardo liked him enough that Leonardo actually illustrated his books on accounting. So that's pretty cool stuff. And he invented double entry bookkeeping. Now, what is double entry bookkeeping? Most of you have some familiarity with a ledger of transactions. It's basically a place where you write down a log of every transaction that's occurred. That's not particularly special. What's special about what Luca did was how he recorded that information. He recorded this information in one place, and he recorded it in a way where it's easy to reconcile. Reconciling means that I can immediately look at all the transactions I've done and quickly determine, for example, what my cash position is. I can quickly figure out how much space I have left on my boat, or if I'm overexposed for a certain risk, or how much money I'm allowed to use for a specific situation. And so his ledgers enable that to happen. And the Medici family, the diagram you saw on the right of the picture there, was actually used these ledgers to transact business. And one of the reasons they became this economic powerhouse of the 1600s was really because they had the ability to manage a very, very important thing very well, which was their capital. And because they could do that, they could essentially dominate trade across an entire continent. And so all from using a ledger. So we, of course, use ledgers today. Bookkeepers basically use the exact same stuff. By the way, if you ever want to look at Pacioli's stuff, it's online. And he wrote a technical specification in 1500, which is basically followed today by accountants. He talks about debits, he talks about credits, he talks about how to resolve things properly. He actually spends more time than most talking about ethics, which is pretty cool. So it's unfortunate that we don't look at his writings first today on this. But this is a world that looks at centralization. It worked better because the Medici family actually kept all those records together. Let's go back to our pink slip situation here. So when I transact peer-to-peer, I am not doing so by going to Luca Pacchioli and asking him for permission to transact the car. I'm doing it in a parking lot with a pink slip. There's two problems with doing this that make things a little bit scary as a purchaser. The first is that it's quite possible that when I go to the parking lot, the pink slip you show me might not be legit. You might have forged it. And if I buy that car from you, I'm walking off with a certificate to nothing, right? That's problem number one. Problem number two is maybe you did own that car, but you made two really great copies of that certificate, and you sold the car to me once, and then 5 minutes later you sold the car to someone else. And so now you've walked away with twice the money in your pocket, and one of the two of us is going to be very upset, right? And so this is called the double spend problem. And really, for the longest time, we haven't been able to solve this. So the way that we've solved this today is through something called the County Clerk Recorder's Office. This is sort of old tech. All of you have one of these probably in the county that you came from. And the County Clerk Recorder's Office is basically a ledger. What they do is they keep track of every single transaction associated with a specific piece of property. And so just like a ledger keeps all the transactions in one place so you can quickly reconcile, when we look up your house address, they will quickly deliver to you all the contracts associated with your house in a row. So let's say that you want to sell your house. The buyer goes to the County Clerk Recorder's Office to request this manifest. What are they doing? Are they trying to prove that you own the house? Well, it's not a judge. This is just a recorder office. But if I go and look at your house and I see that your house has been transacted, say 10 times in the last 100 years, and I see very clean documentation for those last 10 transactions, the odds of this being a fraud are pretty low, right? Also, if the moment I buy the house, I race to record that transaction, it's pretty unlikely they're going to double spend on me, right? And so this office fulfills a very, very important function, but it's centralized, right? So how can we actually take these peer-to-peer transactions, which are decentralized, and have some of the same properties of a centralized system? Now this, in my opinion, which is why it has a little gold star on the top, is Satoshi's greatest moment. And this is really the biggest innovation to occur in digital contracts, at least anything decentralized in the past 10, 20, 30 years. And it starts out very, very simple. So I have a chain of transactions. We're going to call that the blockchain, right? And a blockchain is simply a bunch of blocks that get added over time. And just like you write all the transactions in one place, all these blocks are transactions. And so if I want to, for example, buy a car from Alice, what I'll do is I'll go look up the blockchain, and I will see, well, the car transferred a couple times, but yeah, it looks like it's Alice's car. That's great. I'm going to buy it from her. And when I do, I'm going to race to record that transaction on the blockchain by adding my block on the bottom. Okay? So just like the County Clerk Recorder's Office, what's different? Well, Satoshi wanted this to be decentralized. He didn't want a government office. He didn't want any one person in charge. And so that means there's just a bunch of copies of this blockchain lying around. What happens when there's copies of data lying around from people that don't trust each other? Well, they might mess up some of the entries. They could forge stuff in there. Or they might actually say, like, well, actually, I know that you think this is the version of the history, but actually Alice sold the car to this other person, so ignore this branch of the truth. We're going to trace down this one. And it makes people very nervous. And it's reasons like that that actually prevented this kind of concept from working. So Satoshi did something which was very, very interesting. It sounds extremely simple, but this is essentially why Bitcoin is the way it is. He said, this is a public record. What we're going to do is we're going to use a bunch of hashes to make sure people can't forge elements in the tree. That's actually not hard to do. We know how to use tech to do that. But what we're also going to do is whenever there's a disagreement as to the contents of the blockchain, we will follow one simple rule. By consensus, we will always follow the longest chain only. And so you can see here, there's a blockchain, and the black nodes are basically lots of legitimate transactions. The gray nodes are other kinds of transactions. Maybe they're legitimate, maybe they're not. We don't know. All we do know is that they're not part of the longest chain. And so by convention, all of us in this room are supposed to not look at it. We're supposed to ignore it. And so a few people in the gray blocks might have gotten stiffed from this, but the people whose transactions are on the black blocks can sort of continue working forward with confidence. Let me try to make this a little more real to you. So most of you went and picked up a backpack this morning, I take it. And the line was kind of not well organized, right, in the back? And so when you first started, I saw this in everyone's eyes. People sort of stood in line. They weren't really sure where they're supposed to stand. And they were concerned because they were worried that someone else was cutting in line in front of them. And this is exactly the feeling that you experience when you're standing on the back of a long queue, right? You're worried that all these people milling around are going to start cutting in front of you. Maybe they're going to take the transaction away from you. Maybe they're going to create an alternate blockchain. They're going to go and create a line that goes out the side with their friends, and you're going to be lost. Now, after time passes and you've been at the TSA line for a while, something amazing happens. The line doesn't move. That's not the point. What happens is more people stand behind you. Now, think about that for a minute. When you're in a line, there's much people standing behind you, you can surf your iPhone with confidence, right? Because you know that if anyone cuts in front of you, there's a bunch of people behind you that are going to get mad. There's a collective economic interest in making sure that your place in line is actually good. That is actually why the blockchain works. We have a common interest in making sure that transactions are good. Satoshi set the rules for that in place. And so, by the conventional rules today, if you're on the blockchain now and a few blocks have been appended, maybe 2 blocks, you can consider that transaction to be golden, recorded, and done. And we've now created the same benefits of a county clerk recorder's office from a bunch of people who do not trust each other and really have no other reason than financially shared interest to cooperate. Does that make sense? This is what I think was the biggest innovation in really smart contracts and what enables things to be decentralized. So think about that next time you're in line. So now let's get very specific. Let's take a closer look at what Bitcoin and blockchain is. And we're going to focus on Bitcoin right now. The other talks to follow me are going to talk about Ethereum and other kinds of smart contracts. So a couple statistics. As of last night, there are roughly 17 million Bitcoins in circulation. You can transact these things fractionally, so you don't have just 17 million coins, which is good because the current value of a coin is roughly $8,000. Right? So let's do some math. There's $137 billion of Bitcoin in circulation. That's about 3.5% of the US's money supply. The number of daily on-chain transactions, in other words, people transacting money through the blockchain, the aggregate sum of that's about $5 billion. So we have $5 billion changing hands a day between people who really don't know each other very well. And that's actually very healthy. It means that we have an asset that's fairly liquid, meaning that you can get good liquidity for it. And you can transact. And we talked about mining. Remember, Satoshi set up a world where people get rewarded for participating. There's 144 winners per day, roughly every 10 minutes, where 1,800 Bitcoin is given away. And so if you're the lucky winner that does all this math and your mining rig finds it, you get about $100,000 by today's transaction standards, every 10 minutes, right? And this is designed to kind of make the system work. Let's go take a look at the blockchain itself. Since inception, about 10 years, the current size of the blockchain is about 164 gigabytes, which is big, but not that big, right? Every 10 minutes, there's a new block that shows up. There's a bunch of rules that dictate how that happens. And every block has about 1,500 to 2,000 transactions. It's actually not that much. That means there's only about 3 transactions per second on the network. And the reality is we can only support about twice that before the system kind of breaks down. That's why there's these other kinds of cryptocurrencies and coins that have come into circulation. They're trying to solve this problem. Let's go ahead and take a look at a specific block now, shall we? So a block has a header, just like every other sort of information here. A block it tells you where it is, the height. In other words, how many height or depth, in this case they call it height, how many transactions have occurred before it. This happens to be the 132nd thousandth block, happened to occur 6 years ago, and it has a timestamp. And you see a bunch of hashes. Well, the hashes have lots of leading zeros, which means that whoever created these things was the winner of the math prize, right? They were able to mine something special until they got to those magic hash values. All right, now let's take a look at the transactions, because that's really what matters here. These are transactions, and I know it's hard to see on the screen here, but you can see there's something to the left of the arrow and something to the right of the arrow. It's basically about 2,000 from this wallet, take money, and send to this wallet. And these transactions are exactly what you'd imagine in the pink slip. They have a sender, they have a recipient, they have an amount, and they have a digital signature. The signature is from the sender. And that's really all that's recorded. And I know you can't see clearly on this chart, but the very first entry is actually coins that are showered on the math winner. In this case, they got 50 Bitcoins. And the next transaction here is a transfer. You can see a bunch of keys that are pooling money together that's then being transferred to a bunch of other wallets, other identities. And this is 400 Bitcoins. For those of you who came here thinking that we'd talk about a lot more advanced subjects in Bitcoin, just for fun, this is the Mt. Gox transfer. And so if you know what that is, you can kind of laugh. If you don't, just stay with me, right? So yes. So now let's go ahead and take a look at what it means to be an identity, one of those hashes on the left or right side of the arrow. This is called a wallet. A wallet is an identity, and you participate in the Bitcoin system by essentially creating an identity. And you create a key pair, an ECDSA key pair to be exact. And you can see on the left all that's revealed to the world when you create a key pair. Well, it's a hash of your key and then another hash of it that's called your address. And you can have a 2D barcode of it. And if we want to, we can crawl through the transaction ledger. And we can see that this specific address has received a total of 470 Bitcoins in its life. And it's basically depleted now, right? Now, if you are looking at this from a conventional identity perspective, there's a lot of stuff that's missing. Where's the person's name? Where's the CA that signed this? Where's the validity period? Where's the version number? Where are the delegated rights associated with this key? Can they open a web connection? Can they transfer money? What's their transfer limit? These are all concepts that we're used to having in organizations from the roles that we create. Satoshi had none of that. He said, listen, here's how I know if you're the legitimate transacting party for this organization. You have the private key, and that's it. And so one of the things that's going to cause a bit of heartburn, I think, for people at this conference in the next 5, 10 years is we are now needing to transact with these systems that do not treat identity, roles, and key management in a conventional way. And so just keep that in mind. Now let's look at what best practice is for someone that wants to actually transact, someone create a wallet. This diagram's from bitcoin.org. The first thing you're going to do is you're going to do a bunch of operations involving key management. I'm going to create a key pair for me. I'm going to figure out how to publish that public key to the world, and I'm going to store these keys in a safe way. All common IT and security best practices techniques. Then I'm going to wait for someone to give me money. Now this is interesting. When someone pays me in Bitcoin, we don't open a two-way communication and start a TLS handshake. I just sit there, and they have my public key. And I sit and wait. And at some point, the blockchain will have an entry where the other end of that arrow is going to be my public key, meaning someone transferred money to me in this public ledger. And then it's mine. I can transact from it because that's what the ledger says. So receiving money is actually very easy here. I just sit and monitor the blockchain. Then let's say I want to pay somebody. Well, what I have to do then is I have to create that pink slip, get their public key, get the amount, digitally sign that thing with my keys, and then the final step is basically posting that transaction, finding a way to get that to the blockchain, right? And so this is, you can think of the transactions at the bottom as basically APIs. These are things I have to do with the world. I have to read and I have to write efficiently. On the top, you can think of these as things I have to do to keep my own house in order, manage my keys, sign transactions. And I got to tell you, my previous career involved basically key management, secure device provisioning, and doing this well across a large number of devices in very uncontrolled environments. I would say that the way that this is done right now is not necessarily following best practice. And we have a ways to go in building these systems correctly to do the stuff on the top end. To make matters worse, the bottom end is forcing us to have these transaction systems in a near online state, meaning that you need to be able to transact on behalf of your company at an endpoint that can speak for your company. Right? So these are things that, again, that we're just not quite used to doing, that mostly occurred because Satoshi was probably not an auditor and probably didn't advertise his vitamins at night, right? That sort of thing. So, so let's sort of sum this up. Bitcoin is basically a coordinated, decentralized, meaning there's no one party controlling this, trustless, meaning that once transactions go, they basically ride, and it's coordinated under policy set in motion 10 years ago. It is no central administrator and no governing body. $5 billion a day transacts on this thing in a very stable and transparent way that it actually has more stability than a lot of the world's currencies. Now, it has no governing body, but some of these folks might want to talk to you. The SEC, the IRS, a bunch of US states. We'll talk about that at the end of our next track session. All right? And so I'm going to spend the last few minutes here just talking about what a post-Satoshi world looks like and why this is so fascinating. The first is that there are two conventional ways that we build trust in the world. One is to have the government basically stand behind it. The Postal Service has secure mail, not because the postman drives armored car, right? It has secure mail because people will show up with guns if you mess up the mail. And the government's decided that is the most efficient way to inspire trust in the system. The second thing that we might do is we might have someone step in and be a guarantor. I can buy on eBay with confidence because if something bad happens to me in the transaction, eBay will stand in basically for me and pay me back, right? We've now introduced a third concept. There is a true consensus that's obtained, in this case through Bitcoin, in a way that actually sets things, I don't know if it's right, but set things true based on a very common framework. This is crucial, and this is why people are so excited about these things. The second thing we're excited about is we have internet class, internet style scale here. All I had to do to create a wallet was just generate a key pair. I didn't have to ask for permission from anyone. I didn't have to register. I just had to wait until someone paid me on the blockchain, right? So think about that for a second. I can add a node to this network and immediately transact with anyone else in a peer-to-peer way in the same way that I can route a packet on the internet. That should excite you. And finally, contracts. We talked about ways to send fairly simple contracts to each other and basically record them. What's a company? A company is basically a series of contracts. We have employment agreements with our employers to get paid. Our companies have contracts with their suppliers and have contracts with their customers. And a contract is basically, a company is a sum of these things. If we can virtualize these things in the same way that I could take a bunch of on-prem equipment and stick it at AWS and spin it up and break it down if I needed to, I can do the same thing with a company. And that should both excite you and scare you about what the possibilities are. Right? So in conclusion, we looked a little bit at Satoshi's world. It is a peer-to-peer system based on digital identities. There's no trusted third party. It is decentralized, and it is based on the property of proof of work. All right? And I have just a few minutes now, and so if there's other questions, I can answer them. I can either repeat the question, or if you want to use the mics, I can do that. Yes? Okay, so the question was, in the situation we set up, hypothetical situation of me selling you a car, how do we actually set up double spending? I mean, it's actually not that hard from a criminal's perspective. The Brooklyn Bridge was sold by someone who didn't have the rights to sell it, right? I can quickly do two transactions. In a digital world, I can do two transactions milliseconds away, and you might never actually know that it happened. So the solution to this is basically to check the blockchain, make sure you can transact with that person, and then you basically wait. You wait for enough time where you know that you're not the last person in the line at the TSA, right? And you wait, in this case, 20 minutes to make sure that that money is actually yours and you can continue. So it's not totally frictionless, but this is way, way, way less frictionless than, for example, going somewhere else. The other interesting thing about the transaction, just to kind of go on this, is the reason that we have a lot of processes in place is because if the transactions go awry, we assume we can go to a court of law to fix them. It's actually very expensive to go to a court to fix these things. So if I do the contract right with you, we will never need to go to court. But if I don't do it right, we're going to end up suing each other, and this costs money. And those transaction costs are actually built into how we operate as a society. When you buy a home, there's an escrow agent, there's an inspection, there's insurance that you buy, there's title insurance, there's fire insurance. All these things are actually based on trying to make sure that if something goes bad, the transaction can be unraveled. What Satoshi's world did was actually make these transactions much more definitive and much more quick. And that also kind of warps your head a little bit as you think about this. So I'll take one more question, and then we'll go to our next speaker. Yeah.
Could you elaborate on the transparency format you had next to the
Right. So the question is, can I elaborate on the transparency component? So in any decentralized system that doesn't trust one person, we have to find a way we have to efficiently broadcast the truth to a large number of people. Because suddenly an earthquake might happen and this set of seats might just be disappeared, right? And suddenly this set of people might all turn rogue on us. As long as they're less than 51%, we can go let them do their thing. And so the only way I can guarantee safety and integrity of the transaction is actually to make a ton of copies of everything I've got. And so if every single one of you have a copy of the blockchain, I can handle a third of you going rogue, a third of you dying. And this one will be the genesis on which I create the rest of America or something like this, right? So we can make that happen. And that's why transparency is important. It also is extremely intriguing because it means that a lot of the things that we're used to kind of holding in a proprietary closed way, we we actually have to broadcast. And so privacy folks are truly excited about this kind of stuff.